Let's review what causes cancer. So we've explored the causes of cancer at the cellular level and the subcellular level. So we've talked about some of those things or characteristics of cancer cells that make them different from normal cells, such as, they don't get those signals when the cells are all crowded together to stop growing. They also don't get the signals to self-destruct when there are mistakes. So there are a couple genes that are associated with cancer risk or a higher cancer risk. So normally we have what we call proto-oncogenes. These are genes that turn on cellular division. So when our cells do need to replace themselves or we're growing, those proto-oncogenes will be activated so that the cell reproduces. Now, when those proto-oncogenes are mutated, we call them oncogenes, and they're stuck in the on position. So imagine that you are driving a car and your foot pushes down on the accelerator and the accelerator gets stuck. That is analogous to what's happening with proto-oncogenes when they're mutated into oncogenes. The other type of gene that's really important in this increased risk of cancer are tumor suppressor genes. So normal cells have normal, unmutated, functioning tumor suppressor genes. Like it sounds, these genes suppress the growth of tumors, right? They turn off cell division. They're also going to help with the repair of damaged DNA, or telling that cell you need to destroy yourself, right? Because there's too much damage there. When they're mutated, they don't work correctly. So in our car example, this is analogous to you pushing the brakes, but nothing happens. So when both of these types of genes get mutated, you're stuck in the on position and you're not getting those messages to stop reproducing. So consider what you've learned. What factors contribute to whether or not somebody has these cancer-causing mutations? And I want to emphasize it takes multiple mutations for a cell to become cancerous. Usually a single mutation won't do it, but it will increase a person's risk of getting cancer because then if they get another mutation, it has an additive effect. Some of the risk factors that you may have come up with are things like age. The older we get, the more times our cells have had to replace themselves, the more times our DNA has had to copy itself, and we just get more and more random mutations that build up. Carcinogens are also a really big risk factor. Carcinogens are anything that causes cancer. They're a cancer-causing agent. So radiation, we know, is a carcinogen, right? Those UV rays can cause mutations in our skin cells, but other types of radiation can also cause mutations such as X-rays and radioactive substances. So think about when you go to the dentist and you need to get X-rays, they put that heavy lead vest over your body, and that is to actually protect the rest of your body from those X-rays. Chemicals are, some chemicals are carcinogenic, so gasoline fumes, if you are pumping gas, hopefully those in some states, the nozzle, I guess, that you stick into your car will have a rubber gasket around it to prevent those fumes from escaping. Tobacco smoke, that black charring on meat is actually a carcinogen, and alcohol. Some viruses can also actually cause cancer. So hepatitis is the #1 cause of liver cancer, and HPV is the main cause for cervical cancer. Obesity is also a compounding factor that can increase a person's risk. And, the cause and effect relationship there isn't well understood, but there is a correlation. And then, of course, heredity. You can inherit some of these mutations. Just, take a second, look at this diagram on the right. These are showing the percent of United States or US cancer cases in adults, so people over the age of 30, that are attributed to certain factors. So look at those factors. This is interesting because these factors are things related to someone's behavior. So there are behavior choices we can make to reduce the risk of cancer. Now, we can't change our genetics, we can't change our age, we can't change our gender, which also makes us more susceptible to some types of cancers, but there are some things that we can control. Now, there are a lot of different cancer treatments, which is something we haven't talked about yet. And this is an exciting area that is, still under development. Things are changing. We're adding things to this list. So some of the things that you may have heard about are probably things like chemotherapy, radiation, and surgery. Those are kind of the big three. So if it's a tumor that can easily be removed from the body, then surgery is a good option. Just take out that tumor. Now, if there's a risk that any of those cancer cells have broken off and spread to other parts of the body, something like chemotherapy or radiation therapy might be used, and actually usually more chemotherapy. So chemotherapy is where somebody is having drugs being put into their body, and those drugs target rapidly dividing cells. So it's going to target those cancer cells, those tumor-causing cells. It will also target other rapidly dividing cells in our body, things like our hair follicles or the lining of our digestive tracts. Now, radiation therapy is sort of similar to surgery, but without the cuts on the outside. So radiation does cause cancer, but it can also be used to destroy cells. So radiation gets targeted to the place where the tumor is to try to destroy that tumor. And the surrounding tissues then are very well protected. Some of the newer treatment options are things like immunotherapy, where your own immune system is sort of trained to better find those cancer cells, and then your immune system actually fights the cancer. Now, your immune system is doing that already. It's constantly looking for mutated cells, funny looking cells, and destroying them, but this is going to be a more targeted approach. And targeted therapy, since it's there, this is where drugs or other substances that block cancer growth and can spread, interfere with very specific molecules associated with cancer. So that's going to be very specific to the type of cancer that somebody has. Now, bone marrow transplants is something that is specific to blood cancers, because your blood is actually, those blood cells are made in your bone marrow. So leukemia and lymphoma are those blood cancers. And so those cells in the bone marrow aren't working properly because they're cancerous. So after the bone marrow, your own bone marrow, the person who has the cancer, their own bone marrow actually is wiped out. Then they get a transplant from somebody else that has a similar sort of genetic makeup as them to sort of seed new bone marrow cells, new stem cells that can then make new blood cells for them. And then hormone therapy. This is where someone is getting artificial hormones that are actually depriving cancer cells of the hormones they need to survive. So I guess they're not necessarily getting more hormones, but their own hormones get suppressed so that the cancer cells can't grow and divide and cause problems.